In this video, we're going to learn how to work with STL meshes in Fusion. Now, it's important to note that not all mesh files are created equal. If you create a design in a CAD program and convert it to a mesh file, it's going to be different than something you get from, say, a 3D scanner. We're going to be focused on 3D scanner-based meshes in this video, but most of the tips and techniques will work across all different types of meshes. So to get started, there are a couple of ways that you can bring a mesh into Fusion. The preferred method is to use Insert Mesh on the Mesh tools. We're going to go and find an STL, an OBJ, or a 3MF file and open that in Fusion. Now, it's important to note that STL files are going to contain only triangular mesh elements and nothing else. OBJ and 3MF files can also contain quad meshes or ngons. These are mesh faces that are not just triangular. They also have other information in some cases such as material or appearance and even 3D printer settings. For our purposes, we're going to focus on the STL, but any of the options would be the same. Note that in the Insert Mesh dialog, we have Center, Move to Ground, as well as Flip Up Direction. It is important to note that none of these options will allow you to select specific parts of your mesh and align it to the coordinate system. These are going to allow it to flip based on 90-degree rotations, but they will not allow for precise input based on mesh selections. So if you need to align to a coordinate system or your origin, make sure that that's done before you bring the mesh into Fusion. Most 3D scanning software will allow you to do this, and there are also third-party solutions depending on where your workflow lies. We're going to say OK, and now that we have a mesh body in Fusion, the next step is to double-check the mesh properties. We always want to make ourselves aware of the number of faces that we have in a mesh body, in this case 214,000. As that number increases, you'll notice that Fusion has a harder time dealing with it. One of the main reasons is that every time we hover over a mesh body, it's going to highlight it. And what happens is all 214,000 of those triangles get highlighted. To simplify this, we can right-click on the mesh body and make it unselectable. This means that rotations and movements in the canvas area are going to be much quicker. Personally speaking, I would say that anything over 500,000 faces is going to start to really show a performance degradation in Fusion. So if you have a large mesh file, one of the next steps is to remesh that to reduce the mesh count. Let's go ahead and take a look at some of the mesh tools that we have to simplify and smooth out this mesh. One quick note for you, if you do have to align your mesh body in the coordinate system, you can go into Direct Edit. We're going to select the mesh body, and we can use Direct Edit tools to create construction planes by selecting specific points on the design. In this case, for example, I'm going to create a 3-point plane, selecting points on the edge of the mesh. The reason this is important is because we can do this in Direct Edit, but we aren't able to select individual mesh elements when we're not in Direct Edit mode. We can now show the origin, and we can use tools like Measure and find the angle between our current mesh position and the default angle, in this case 0.15 degrees. That's close enough that it's not something that I would worry about, and for a design like this, which is a belt guard for an alternator, really doesn't require us to be that precise. But if you're working on mechanical components and you need to get it just a little bit closer to precise, then you can use those tips in the Direct Edit tools. Now, as for remeshing and smoothing out a mesh, I suggest that you do that while capturing design history. If you happen to open a mesh file using File Open or importing it into your data panel, you will also want to make sure that you right-click at the top level and you capture design history. That'll be off by default for any neutral imported file formats. So under Modify, there are two main tools that we're going to focus on. That's Remesh and Smooth. We also have the option to reduce the mesh count. This oftentimes is not a great option when we're dealing with scanned meshes. So we want to focus on Remesh because inside of Remesh, we have Preserve Sharp Edges and Preserve Boundaries. There are two different types of mesh elements we can create, an adaptive or a uniform. When we use the adaptive option, we have a shape preservation slider. When we use the uniform option, it's going to be using a uniform mesh element size based on the density that we choose. We're going to go ahead and select the mesh body using the default density of 0.2 and a uniform type and say OK. What happens is now Fusion will go through the entire mesh file and it'll change the element size based on our settings. If I drag this back in the timeline, you can see that we've got some mesh elements that are extremely small and some that are a little bit larger. But after a remesh, they're all going to be a consistent size. What you might find is that you see a little bit of loss in the original shape of your design once you start to remesh. So it's always something that you should be aware of and careful with your density settings. The next step that we want to go through is smoothing our design. Now, smoothing doesn't have a shape preservation option. We simply have a smoothing slider. This is going to determine the degrees of smoothness that will be applied. What this is essentially doing is it's taking a look at mesh elements and the angle between adjacent faces. So what ends up happening with smoothing is when you have areas of transition, like essentially a filleted corner, as we apply smoothing, those filleted corners become flatter and flatter. So if we drag the timeline back, you can see that this entire face has actually changed angles as we go through the smoothing process. One thing that I would note is that if you do smoothing before you do a remesh, oftentimes you'll get a more accurate model and a smoother response. But it is going to be model dependent, so make sure that you do play around with the order of operations and also the settings within each tool. So this looks pretty good so far. So the next step in our process is to figure out how we can gather information and begin making our designs based off what we have here. Now, there are two main workflows or methods that we could use to recreate a mesh-based design. One is the use of mesh section sketches, and the other is using freeform modeling. We're going to start with mesh section sketches by selecting the body and allowing it to create a section sketch. I'm going to repeat this process using my right-click marking menu, and in this case, I want to rotate that plane and just continue to create additional sections. I'm going to do this one more time, but in this instance, I want to use the plane that we created, and I want to slightly drag that inward to get a better section of the mesh. Oftentimes, you'll note that at the very edge of a mesh, you'll start to get a little bit more variation, and this is very true when you're talking about scanning of thin objects. So now that we have a couple of mesh sections, what can we do with them? Well, in the Sketches folder, you'll notice that each sketch has a sub-mesh section. We need to edit each sketch, and from our Create menu, fit curve to mesh section. This is a little bit tricky, and you need to use a little bit of information about the design intent. For example, if the original design contained straight lines, we may want to use the Straight Line tool to recreate those sections with straight lines. This will allow us to rebuild the design using just those straight lines. Keep in mind that each of these straight lines is not fixed or constrained in space. So we may want to use fix unfix for each of them. And then we can use the endpoints to extend and trim the overlapping sections. So using trim and extend, we can build out a flat line-based version of our cross-section. In this case, I'm going to move on to the second sketch, and I'm going to repeat this process using a spline. When we take a look at fitting spline curves, we have to be very careful with our tolerance values. Remember that these mesh sections are created based on a lot of small triangles. As we create a spline or multiple splines through here, using our tangency option, we can create multiple splines through the design. But if we come back and we take a look at, say, the curvature combs, we'll see that we have a lot of variation in the spline. And once again, this is purely based on the fact that we're trying to attach it to a bunch of small triangles as the spline is moving along. So as we're recreating designs, using things like a spline in a mesh section will not give you the best final surface results. It's always a good idea to think about the design intent and use these tools to your advantage, but make sure that you understand the limitations and the outputs that you're getting from each one. Now that we've seen a little bit on how to create mesh section sketches, let's talk about the other option, which is creating a freeform body. Using Create Form, we can start a freeform body by using the Face tool and Object Snap. If we're using Object Snap, we can begin by snapping directly onto the mesh body. Using this tool, I'm going to go ahead and create a couple of faces across the design, making sure that I do snap to the common endpoints. As we do this, the new faces will be directly on the mesh body. I'm going to go ahead and add one more here, and then we'll say OK. To make this a little easier to see, I'm going to go into the Bodies folder, right-click on the mesh, and change its opacity to 40%. Now we can see that we've got a freeform face that lies directly inside of that mesh. I'm going to go ahead and use Edit Form to continue to model this design out. From a right-hand view, I'm going to hold down Alt and continue to model this following the curvature of the design. Each time I let go and hit Alt again, I'll be extruding a new face. If we have Object Snap turned on while we're doing this, the faces will snap directly to the mesh body. We can see this does produce some potential problems, so if we use Ctrl-Z and undo, and we turn off Object Snap, we can begin manually creating these faces. And as we manually create the faces, they're no longer snapping to the underlying mesh body, which means we're going to have to use another tool called Pull to bring them back in line. So from our Modify dialog, we'll select Pull. I'm going to select all of the vertices in the design and select OK. This will pull them down to the mesh reference, and you can see that everything looks like it's created in pretty close fashion. I'm going to go ahead and say Finish Form, and now we have a NURBS surface that closely resembles the scanned mesh that we brought into Fusion. There is one more method that I think we should mention before we finish this video, and that's the ability to convert a quad mesh directly to a freeform body. So if I insert another mesh, in this case a quad mesh version, I'm going to go ahead and center this, move to ground, and say OK. Now this is a quad meshed version of the same scan in a much lower resolution. When we're converting a quad mesh to a freeform body, Fusion really likes to see 10,000 faces or less. So keep that in mind as you're converting your own. If you do have the product design extension, it's important to note that under Convert Mesh, the organic option will take a triangular mesh, convert it to a quad mesh, and convert it to a freeform body. If you don't have the product design extension, you will need to convert it to a quad mesh externally using one of many different resources. Once inside of here under Utilities, we can use the Convert option, selecting the convert type quad mesh to T-spline, and select our quad mesh body. From here, we now have a quad mesh T-spline body, which can be manipulated and adjusted as needed. For example, if I don't feel like we need this edge, I can select it and delete it to clean up the quad mesh. If I feel the same with this one, I can delete it and clean up the quad mesh there. We can also get rid of this edge here. And if we want to make any adjustments to the design, for example, if we need to pull up a small section here, we can begin to manipulate it directly. Once we're done working with a quad, we can select Finish Form, and once again, we now have a surface. If I hide the edges using Ctrl-4, we have a surface that we can work with, but it is important to note that there are some potential issues. When you convert a quad mesh, you need to be very careful with the end result, and oftentimes it requires you to go back in, using tools like Utilities and Repair Body, as well as using other tools like Utilities Make Uniform, as well as Modify and Smooth. The conversion quality is going to directly impact the final surface that you get, so the more time you spend working on that quad mesh conversion or manipulating it in the freeform environment, the better the end results are going to be. At this point, those are the main ways that we can work with scanned or reference meshes in Fusion by creating mesh section sketches, by creating freeform bodies, or by converting it to a quad mesh and converting that directly to a T-spline body. How do you work with meshes in your own designs? Do you bring mesh bodies into Fusion, and is there another workflow that you have that we didn't cover here? If you have any questions, please leave them in the comments. As always, thanks for watching, and we'll see you in the next one.